Okay, welcome back. Just a quick follow-up here to the chain rule. I've got chain plus product rule together as option 2. If you remember, when we saw the quotient rule, I said our first option will be to use the quotient rule for questions that look like this, questions that have a division, but that in the Ontario curriculum, the quotient rule is optional. So we'll take a look at the second option now. I'm just going to get rid of that. First option, of course, was just to go with a straightforward quotient rule. And this is more or less the same example that was done in the quotient rule video. Slight change, added the number or changed the number 3 to a 1 here to avoid the simplification of factoring at the end. So basically, g divided by h, we take the derivative of the top times the unchanged denominator, subtract the unchanged numerator times the derivative of the denominator, square the denominator, and this is what it looks like. So derivative of the numerator minus derivative of the denominator here, denominator squared, and as we follow it through, again, same question more or less that we saw before, we end up with 18x squared minus 6x plus 22 divided by 6x minus 1 quantity squared, and the numerator is still factorable, so 2 times 9x squared minus 3x plus 11. So that was option 1, we've gone through that. If we look at option 2, so my mouse will react here, the exact same question. I guess I could call it example 2 in this case. Although again, it is example 1 just done another way, so I don't suppose it matters too much. So in this example, we're going to rewrite the existing quotient as a product. The numerator stays the same. The denominator now has an exponent of -1. That's how we handled our derivatives at the very start. If we had divided by x squared or something, we rewrote it as x to the -2. And so same idea here. We can rewrite the question with as a multiplication. The denominator now has a negative exponent. And so the process will be basically using product rule. I'm taking the derivative of the first term here, getting the 6x plus 2. Second term unchanged, plus first term unchanged, and derivative of the second term. Now the derivative of the second term, of course, is going to be done using a chain rule over here. And so we're taking the derivative of the brackets essentially versus the brackets, and then the brackets versus x with respect to x. And so 6x plus 2, when we have the negative exponent, that means really this is in the denominator, so rewritten here with the denominator. Unchanged, and then this simplifies. The exponent gets multiplied out front, so there's your -1. Subtract 1 from the existing exponent, we have a -2, and the derivative of 6x minus 1 is just 6. Now the rest of it, of course, is just the math. To simplify, 6x plus 2 over 6x minus 1. This bracket is unchanged, and -1 times 6 is also in my numerator. 6x minus 1 to the exponent -2 suggests that 6x minus 1 squared is in my denominator. Common denominator then is 6x minus 1 squared, so multiply the first fraction here by 6x minus 1 over 6x minus 1, and then expand the numerator. I've multiplied also through the -6 times each of these. So -18 squared minus 12x plus 24, and then basically collect like terms on the top in the numerator. And you see that we end up with the exact same, obviously, the exact same expression, and it simplifies the same way in the last step. Okay, so for today, basically the questions will be attempting different questions with both the quotient rule and the chain and product rule, so you get comfortable with both, and maybe you see which one you prefer, and if there are times when you prefer one over the other, or if it's always you have a preference of the quotient rule specifically or the chain and product rule in combination specifically. That is all for today.